So what we're trying to find is the area bounded by these two functions. Let's go ahead and model the situation. In terms of x's, we're going to go top minus bottom. So I chose the top function, clearly the linear function here, and then minus the lower function, the parabola. All that is protected, and this needs a dx. So you're going to use the x coordinate here, the x coordinate there. So we're going to go from -3 to 2. Now, the purpose of this video is not to do the actual arithmetic of things. It's to demonstrate how to do this in terms of y. So here, let me just tell you that you do all of the antiderivatives, you evaluate it from here to here, you're going to get this number. So now if they want us to do this problem again in terms of y's, we're going to need to get these x's alone so that they are in terms of y's. So we have x equals plus or minus the square root of y, and we have x equals this. If you're going to do this in terms of y, like a dy, then it's going to be not top minus bottom, no, but it's got to be right minus left. And when I look at this black region there, I just don't know which of these functions is on the right, which one's on the left. And if anything, it looks like the parabola is both on the left and on the right. I'm just confused here. Look at this triangle here that I am constructing. It's a right triangle. It is not drawn to scale, no. But the base of this triangle is 9, and so is the height. So we know that the triangle here, this triangle, the large one, it has an area of this much. And what's the point of doing that? Well, here is the point. Let's focus on this blue region. Let's find the area of the blue. We can find the blue one in terms of right minus left, because if you look at the blue region, I think it's clear which picture is on the right and which one's on the left. The one on the right is the line, and the line has this equation, 6 minus y. And from that, we're going to take away this function here on the left. Now, do note that this portion of the parabola, that would be your positive square root y, and this one would be negative square root y. So back on the blue, this is the one on the right, minus, and this part on the left is square root y. And let's protect all of this with a dy. Now, what about the integration limits? Well, since this is dy, we need some y values, y coordinates. Well, look at this blue region. What is the lowest and the highest y coordinate? The lowest y coordinate is 0, and the highest y coordinate is 4. So we're going from 0 to 4. What about now the area of the red? Now let's go right minus left, because it has to be in terms of y's, because they wanted y's. Well, here on the red, the picture on the right would be negative square root y. And from that, we're going to take away the graph on the left. Well, what is the equation of this vertical pillar, this vertical beam? The equation there is x equals -3. That's the graph that's on the left. So I'm going the picture on the right minus the picture on the left. Now it's lowest to highest. Since this is dy, I need the lowest y coordinate to the highest y coordinate. The lowest y coordinate of the red region is 0, and the highest y coordinate is going to be 9. In terms of why the strategy was to enclose the whole thingamajig with a triangle, and that's the 81/2. And then if you take the triangle, and if you take away the blue, and if you take away the red, you're left with the black. And that was the goal. The area of the black was, well, the triangle, and then you take away those two colored pockets, and you're left with the area of the black, and you can confirm that this gives you the same answer as when you did it in terms of x's. So this is one way of doing it in terms of y's. There might be another way, but this technique, it also works.